3D Geometry Sheet 1. Problem 1, we have a triangle ABC with A being 2, 3, 5, B minus 1, 2, 2, C lambda 5 mu. The median through A is equally inclined to the axis. The x, y, and this is the median. Let's say this is D, right? And G, being the midpoint of BC, would have coordinates from section formula lambda minus 1 by 2, 7 by 2, mu plus 2 by 2, right? These would be the coordinates of the section formula. Now, the direction ratios of AD would be this minus 2, 7 by 2, minus 3, mu plus 2 by 2, minus 5. These would be the direction ratios of AD, right? And they must be equal. They must be equal because AD is equally inclined to the three axes. So, its direction ratios must all be equal. Yes or no? Its direction ratios must be equal. That means lambda minus 1 by 2 minus 2 must be the same as 7 by 2 minus 3 must be the same as mu plus 2 by 2 minus 5, etc. And this makes lambda and mu available to you. About it? Got me? A mirror and a source of light are situated at the origin O and a point on the x-axis. OX is the x-axis, respectively. So, this is the x-axis and this is a mirror placed at O. A ray of light from the source, this is the source, and there is a ray of light from the source that strikes the mirror and is reflected. The incident ray, this is the reflected ray. If the direction ratios of the normal to the plane are 1, minus 1, 1, this is the normal to the plane. Direction ratios along the normal are 1, minus 1, 1. That means a vector along the plane would be I minus j plus k. I minus j plus k would be a certain vector along the normal, right? Minus j plus k. Although it's not a unit normal, it's just some normal along the plane. A vector along the normal. Then the direction cosines of the reflected ray. Now, let's say LMN are the direction cosines. So Li plus Mj plus Nk be a unit vector along the reflected ray. Unit vector along the reflected ray in this direction. Now, in a direction opposite to the incident ray, a unit vector would be I cap. That's along the x-axis, right? This vector is the angle bisector between these two vectors, Now, tell me this. If I have a vector A, any vector A, and I have another vector B, alright, a vector A and a vector B. What would be a vector along the angle bisector between A and B? What would be a vector along the angle bisector between A and B? Huh? Yes. I mean, realize that obviously the resultant of A and B will not be equally inclined to A and B. I mean, it'll have closer proximity to the one which has greater magnitude, isn't it? So what you do is a practical approach to find the vector along the angle bisector between A and B would be, well, seek a unit vector along A which is like A by mod A. A unit vector A is, unit vector in the direction of A is A by mod A. The direction is not perturbed, right? A unit vector along B would be like B by mod B, right? Now, the direction of A is preserved, the direction of B is preserved, right? And now I have two vectors of equal magnitudes in the direction A and B. Do you realize that their resultant would show equal proclivity to the directions of A and B because they are of same magnitude. So the resultant of these two, which is like A by mod A plus B by mod B, would exhibit equal inclination to both A and B. This is the resultant of these two unit vectors, is it not? Now, so this is obviously then along the angle bisector between these two, right? And any vector along this would be along the angle bisector. So the set of vectors along the angle bisector would be like lambda times this vector. So lambda times A by mod A plus B by mod B would always be a vector which would be along the angle bisector between A and B. Lambda times A by mod A plus B by mod B would always be a vector along the angle bisector between A and B irrespective. Got me? Now, once we have this settled, then it's no tall order looking at this problem in this view. Can I wipe this off? Create room. Look. Along the reflected ray, I've taken direction cosines L, M and N. That means Li plus Mj plus Nk must be a unit vector along the reflected ray. In this direction, a unit vector is I, right? That means a vector along the angle bisector would be I plus this, yes or no? A vector along the angle bisector would be I cap plus this, because this is one unit length, this was a unit vector, right? So a vector bisecting the angle between the incident ray and reflected ray, which must also be along the normal, Now, can I then not say that a vector, any vector along the normal is like a L plus 1 I cap plus M j cap plus N k cap? This is a vector along the angle bisector between A and B, right? And this vector is parallel to this vector. This vector is known to be along the normal, right? So if this vector is parallel to this vector, their corresponding I, j, k coefficients must be proportional. That means L plus 1 by 1 must be M by minus 1 must be N by 1. How about it? Yes or no? Clear? Now, in a real situation, in an MCQ kind of a situation, then what you do is, well, you are looking at L, M and N satisfying that condition. You must check from the options. Which of the options will satisfy this condition? Otherwise, in a more rigorous manner, well, we have this condition and also the condition L squared plus M squared plus N squared equal to 1. Right? So that we have L squared plus M squared is like a L plus 1 whole square, right? Because these are direction cosines, some of the squares must be 1. M written as L plus and N written as L plus 1 whole square. That's equal to 1, and you can solve for L, and therefore M and N as well. But then you don't do this. You can solve for L, M and N, but you don't do this. You just stop here and check from the option which one is matching this or fitting the bill here. Okay. Shall we proceed? Shall we proceed then? Set of planes x minus cy minus bz equal to 0, cx minus y plus az equal to 0, another plane, and the third plane bx plus ay minus z equal to 0, pass through a straight line. That means these planes intersect along the same line, Then we need to find the value of a squared plus b squared plus c squared plus 2abc. Okay. Now, along the common line, there are x, y, z's. Along the common line of the three planes, there are x, y, z's that will satisfy this equation as well as this equation, right? So all that you need to do is, from these three equations, eliminate x, y, and z. Eliminate x, y, and z, right? That will give you a condition connecting a, b, and c. And then to eliminate x, y, z, like we've done while I was discussing 3D geometry, to eliminate x, y, z, you populate the coefficients and constitute a determinant that is like 1 minus c minus b. That's how you eliminate x. C minus 1 a, b a minus 1 equal to 0. That's how you eliminate x, y, z from these three equations. Got me? And then you will get this expression. Once you expand this determinant, you will get this expression in place. Just expand and tell me what the value turns out to be. 1. It turns out to be 1 by when you expand this determinant. Simple. Suppose there are two planes, a1x plus b1y plus c1z plus d1 equal to 0, and a2x plus b2y plus c2z plus d2 equal to 0. These are two planes, plane P1 and plane P2. Sometimes they'll say that given a line P1 and P2, what it really means is the line that is being sought after is the intersection of these two planes. The intersection of these two planes would be the line that one is seeking. So if somebody gives you these two equations and says given a line this equal to 0 and this equal to 0, what it really means is the intersection of these two planes is that line, right? Now, how does one find the equation of the line which constitutes the intersection of these planes, right? Well, if you're familiar, obviously you are, the equation of a line in the normal form is like x minus x1 by some a equals y minus y1 by b equals z minus z1 by c, where a, b, c are direction ratios and x1, y1, z1 is any point lying on the line, right? And ai plus bj plus ck is a vector parallel to the line, not normal to the line, it's along the line. Yes. For this, a1i plus b1j plus c1k is normal to the plane, but for that, ai plus bj plus ck is parallel to the line, right? So then, now, x1, y1, z1 is any point on the line, which means any point of intersection of these two planes will do, right? Any point of intersection of these two planes will do. All that I need to find is one set x1, y1, z1 which satisfies this equation as well as this equation. That must be along the common locus, the line of intersection of the two planes. So to find that x1, y1, z1, you can deploy anything which is convenient to you. For example, in these two equations, you can take z as 0. The intersection of these two planes, you can take, let's say, z as 0 and solve for x and y from these two simultaneous equations, right? You can take a point of intersection of these two planes as x1, y1, z1, where z1 is 0, put z1 as 0 and solve for x1 and y1, right? So you get x1 and y1. So x1 and y1 would be known once you solve the simultaneous equation by putting z1 equal to 0. So then z1 we have chosen to be 0 and x1, y1 we have solved for from the simultaneous equation, right? Now, this line lies on P1 as well as P2, right? That means the vector a1i plus b1j plus c1k, which is normal to the plane, is also perpendicular to the line. Yes or no? Because this line is along the plane Whereas A1i plus B1j plus C1k is perpendicular to the plane, right? That means A1i plus B1j plus C1k, the normal to the plane, must be perpendicular to AI plus BJ plus CK, which is along the line and therefore along the plane, right? So A1i plus B1j plus C1k dot AI plus BJ plus CK. That's zero. That's zero. Normal to the plane, perpendicular to any line lying along the plane. Normal to the plane would be perpendicular to any line lying along the plane, which means AA1 plus BB1 plus CC1 is 0. The dot product, right? And similarly, the line lies on this plane also because it lies along the intersection of the two planes, so it lies on both the planes. So this line lies on this plane. Now same stuff for this plane, A2i plus B2j plus C2k, normal to the plane, must be perpendicular to the line AI plus BJ plus CK, right? The dot product therefore 0. Dot product of A2i plus B2j plus C2k and AI plus BJ plus CK must be 0, right? Am I confusing you? No. AA2 plus BB2 plus CC2 is 0, right? And then from the rule of cross multiplication, what you could do is A by B1C2 minus B2C1 as minus B by A1C2 minus A2C1 is C by A1B2 minus A2B1, right? That's what you get from these two equations using cross multiplication. Or what you can, so A could be selected as this number, B could be selected as minus of this number, and C could be selected as this number. So you could choose the direction ratios as A could be chosen as B1C2 minus B2C1, or K times this. K times this, the K anyways would get cancelled, so it's alright. And similarly, B chosen as A2C1 minus A1C2 and C chosen as A1B2 minus A2B1 or its multiple. And then you can plug in the same and you'll know the equation of the line represented by these two planes. The line represented by these two planes is available there, right? That's the symmetric form, and this is the unsymmetric form of the equation of a line. This is the unsymmetric form, that's the symmetric form. So our migration from the symmetric to the from the unsymmetric to the symmetric form can take place with the help of these calculations. Clear? And once you know the equation of a line, you know the equation of another line, you can find the shortest distance between those two lines. It's given you the result, right? So given those two planes in the given problem, there are two planes which actually means a line. If there are two planes, that is problem 4, the shortest distance between the z-axis and the line x plus y plus 2z minus 3 equal to 0, and the direction ratios could be converted into direction cosines, a by root a square plus b square plus c squared, b by root a square plus b square plus c squared, etc., right? So these could be converted into direction cosines. And the z-axis can also be written in the symmetric. The equation of the z-axis is actually x by 0 is y by 0 is z by 1. That's the equation of the z-axis. That's the equation of the z-axis, where L is 0, M is 0, and N is 1. N is 1. That's the equation of the z-axis, right? That's the equation of the z-axis. So you know L1, M1, N1, you know L2, M2, N2, X1, Y1, Z1, 0, 0, 0, X1, Y1, Z1, and X2, Y2, Z2. And you can just apply the formula and find the shortest distance between those two lines. So I'll leave that for you. You can just get hands-on with those calculations later. This is a line. It intersects the curve xy equal to c squared for at z equal to 0, right? So in this case, if you put z equal to 0, you clearly have x equal to 5, isn't it? 3 plus 2, 5, y equal to 1, and z is 0, right? and this lies on xy equal to c squared. This lies on xy equal to c squared. So xy equal to c squared means c squared is 5 into 1, or c can be plus or minus root 5. And I'm not going to do 6 for you. There is use of just distance formula, just direct distance formula, nothing else. Can I wipe this off? Is this understood by all? Now we need to find in problem 7 the minimum value of x square plus y square plus z squared, given that ax plus by plus cz is some p. Given that ax plus by plus cz as p, we need to find the minimum value of x squared plus y squared plus z squared. Hey, if you recall Cauchy-Schwarz inequality, which really is about ax plus by plus cz whole square less than or equal to a square plus b square plus c square into x square plus y square plus z square. That's actually Cauchy-Schwarz inequality, right? And this is Cauchy-Schwarz inequality, really, isn't it? Did I discuss Cauchy-Schwarz in vectors? Yes. So then this is p squared. Left hand side is p squared less than or equal to a square plus b square plus c squared into x square plus y squared plus z squared. Clearly means that x squared plus y squared plus z squared greater than or equal to p squared by a squared plus b squared plus c squared. That means minimum value of x squared plus y squared plus z squared must be p squared by a squared plus b squared plus c squared. Direct consequence of Cauchy-Schwarz inequality. Got me? So which is Bombay? 7 Bombay. Can I wipe this off? From the discussion that I had on the angle bisector, the resultant being equally inclined to two vectors. Well, if there are two vectors that are of same magnitude, then the resultant would be equally inclined to all of them. If there are three vectors of the same magnitude, then the resultant would be equally inclined to all three, isn't it? If there are three vectors of equal magnitude, then the resultant would be equally inclined to all three. You buy that argument? Now that's exactly what problem 8 is all about. We have direction cosines of a line. There are three mutually perpendicular lines. There is a line which is like one line which is parallel to the vector A, having direction cosines L1, M1, N1, that is L1I plus M1J plus N1K, which is a unit vector along one of the lines. B, a unit vector along another line is like L2I plus M2J plus N2K. C, a unit vector along the third line will be L3I plus M3J plus N3K, right? We need to find a line equally inclined to these three mutually perpendicular. It's also given that A dot B is B dot C is C dot A is 0. That's also given. They are mutually perpendicular. A dot B is B dot C is C dot A is 0. That's also given. That's also given in the problem, right? We need to find the direction cosines of a line that is equally inclined to these three lines. Now, one thing for sure, any line which is equally inclined, any vector which is equally inclined to A, B and C would be like a L1 plus L2 plus L3 I cap plus M1 plus M2 plus M3 J cap plus N1 plus N2 plus N3 K cap will certainly be a vector equally inclined to A, B and C. This is the resultant of A, B and C, isn't it? A plus B plus C. And since A, B, C are of the same magnitude, this would be equal. These are all unit vectors. This would be P would be equally inclined to A, B and C. P would be equally inclined to A, B and C. We need a unit vector along P to arrive at the direction cosines along P. To find a unit vector along P, what would we need? We would need the magnitude of P. divide P by its magnitude, we would get the unit vector along P, and the corresponding I, J, K components would be the direction cosines parallel to P. Yes or no? So what's magnitude of P? Magnitude of P squared is like L1 plus L2 plus L3 whole square plus M1 plus M2 plus M3 whole square plus N1 plus N2 plus N3 whole square. And then evidently L1 squared plus M1 squared plus N1 squared is 1, L2 squared plus M2 squared plus N2 squared 1, N1, N2, N3, etc. 1. So that makes it 3 plus, realize that we have like terms of the following kind. For example, 2 times L1, L2 plus M1, M2 plus N1, N2 plus 2 times terms of this kind. See, L1, L2 plus M1, M2 plus N1, N2 plus 2 times L2, L3 plus M2, M3 plus N2, N3, etc. And realize those would be 0. Why? See, L1, L2 plus M1, M2 plus N1, N2 is 0. Why? Because A and B are perpendicular. So these terms would go into oblivion because of orthogonality amongst AB and C. These terms will all vanish. Right? So then we are simply left with 3. So magnitude of P therefore is root 3. Magnitude of P is root 3. Therefore a unit vector along P would be this by root 3, this by root 3 and this by root 3. Yes or no? This by root 3, this by root 3, this by root 3 would be a unit vector along P. So then what would be the direction cosines of P? The L would be this by root 3, M would be this by root 3, N would be this by root 3. Those would be the direction cosines along P or parallel to P. Got me? So that makes option B eligible. Nine is a direct consequence of the formula. Coplanarity of 2 lines. X2 minus X1, Y2 minus Y1, Z2 minus Z1, L1, M1, N1, L2, M2, N2, etc. equal to 0. And you can solve for lambda, right? So I'm not doing this for you. Problem 10. We have 2 lines that are coplanar. Alpha minus delta is Y minus A by. Alpha is this is line 1, this is line 2, and they're known to be coplanar, and it's given that alpha gamma is not beta delta, You need to find the equation, the common equation, the equation of the common plane between these 2 lines, right? 2 lines, if they are coplanar, you can find the equation of the common plane, right? The equation of the common plane would be, again, direct formula, the equation of the common plane would be x minus a plus d, y minus a, z minus a minus d, alpha minus delta, alpha, alpha plus delta, beta minus gamma, beta, beta plus gamma. That equal to 0 is the equation of the common plane. Haven't I discussed this in the class? That's the equation of the common plane between the 2 lines, right? We just need to simplify this. You can say this is column 1, this is column 2, this is column 3. Realize that if I added these 2 and subtracted twice, this will become 0, isn't it? If I added these 2 and subtracted twice this, if I added these 2 and subtracted twice this, it will become 0. So then the deemed operation is on column C1. Column C1, I perform the operation C1 plus C3 minus 2C2. That's the proposed operation. And because I can make these 2 terms 0 here. And then I can expand about this column. The determinant could be expanded about this column, right? So then perform on C1, C1 plus C3 minus 2C2, right? And that gives me like x plus z minus twice y minus a, y minus a, z minus a minus b, and then 0, 0, alpha, delta, theta plus gamma. That's equal to 0. That's the determinant manipulation that I carry out. Two A will get cancelled. Right? 2A would get cancelled. When I add these two, there is a minus 2A, and then minus 2C2 would have 2A cancelling off. So then I expand about this. When I expand about this, these two will contribute nothing. And this one gives me like a x minus 2y plus z into alpha into beta plus gamma minus beta into alpha plus delta. That equal to 0. Or x minus 2y plus z into alpha beta gets alpha gamma minus beta delta equal to 0. Hey, but this is given to be not 0. So this must be 0, which means x minus 2y plus z equal to 0 is the equation of the common plane. That's the equation of the common plane. Hey, again, it's no rocket science to figure out what's happening in a sphere. Because, say, if x naught, y naught, z naught is the center of the sphere and r is the radius of the sphere, then if x, y, z be any point on the sphere, then the distance of that point from the center must be equal to r. So that's like x minus x naught whole squared plus y minus y naught whole squared plus z minus z naught whole squared equal to r squared. That's the equation of the sphere. And in general, it could be written as like a x squared plus y squared plus z squared plus 2gx plus 2fy plus 2hz plus some c equal to 0. Like for a circle, the sphere could also be written in this format. In which case, again, the center of the sphere will turn out to be minus g minus f minus h, and the radius of the sphere is going to be g squared plus f squared plus h squared minus c. Square root of that will be the radius of the sphere. Right? That's all that you need to know in sphere. If you know this much, then you are eligible for the next problem, problem 12. Can I? Now, equation of the sphere which passes through 3 points, a point A which is like 1, 0, 0, point B which is 0, 1, 0, a point C which is like 0, 0, 1. Now, what we are seeking is a sphere passing through A, B and C. We are seeking a sphere passing through A, B and C and of the smallest possible radius. Smallest possible radius. Now, obviously, given 3 points, the sphere is not uniquely determined, right? You can have very many spheres. Given 3 points, you can have very many spheres. Of those spheres, we are seeking one with the smallest permissible radius. One thing, any 3 points will always be coplanar, isn't it? Any 3 points will always be coplanar. The condition would be required for a 4th point for coplanarity, but 3 points will always be coplanar. A triangle could be constituted out of any 3 points, right? Now, I mean, as long as they are not collinear, that is. For linear, you can't. First of all, with these 3 points A, B and C, can I create a circle? Yes, that will be the circumcircle of triangle ABC. The circle passing through AB and C would be the circumcircle of triangle ABC, and that would be unique. That would be unique, isn't it? So, the circle through AB and C would be the circumcircle of triangle ABC, right? Now, do you realize that, check out these numbers, ABC will constitute an equilateral triangle, isn't it? Distance between A and B is the same as distance between B and C is the same as distance between C and A. So this is an equilateral triangle. This is an equilateral triangle. The circumcenter of the equilateral triangle, will coincide with its centroid. Yes or no? So now, the centroid therefore, which is easy to find, x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, z1 plus z2 plus z3 by 3. That's going to be the centroid as well as the circumcenter, center of the circle, circumscribing the triangle ABC. The circumcenter same as centroid will be 1 by 3, 1 by 3, 1 by 3. Right? That's a center of the circle circumscribing the triangle, the circumcenter of the triangle ABC. Now, the radius of the circle would be distance between O and A or O and B or O and C. That's going to be the radius of that circle, right? So, the radius of the circle passing through A, B and C is going to be root 2/3 whole square plus 2 into 1/3 whole square, right? Distance formula. Isn't it? 1/3 minus 1, 2/3 whole square plus 1/3 whole square plus 1/3 whole square, which is 2 into 1/3. Isn't it? 4 plus 2, 6. So that makes it root 6 by 3. That makes it root 6 by 3 as the radius of that circle. So now we know the center of the circle, which is 1/3, 1/3, 1/3. And we know the radius of the circle, which is like root 6 by 3. Now, given a circle, how many spheres can pass? Let's say this is a circle. This circle, the one passing through A, B and C, let's say that's the circle, right? Realize that one way to construct a sphere is like this. Yes or no? With this being the equatorial plane. This is one of the circles. This is one of the spheres in which the equatorial plane is at a distance from the circle, right? Now, this, you can't do anything about the circle. It has radius r and it has center. That's already prefixed A, B and C, right? Now, you can always move the sphere up and down. Another way to construct. Now, in this case, do you realize that r, the radius of the sphere, is greater than small r? R, the radius of the sphere, is greater than small r. Now, create another sphere by moving it up. So now, create a sphere in which this becomes the equatorial plane. So I've created a sphere R in which the radius is small r. Isn't it? So do you realize that This is the sphere of smallest radius. Any other sphere will have a radius greater than small r. This is the sphere of smallest radius. That means the sphere of smallest radius would have its equatorial plane coincide with this circle, will have its equatorial plane, equatorial circle coincide with this circle. That means now the radius of the proposed sphere would be small r, this, and the center of the sphere would be this, right? That would be the sphere of the smallest possible radius. Got me? That means that sphere, equation of that sphere is going to be x minus 1/3 whole square, y minus 1/3 whole square plus z minus 1/3 whole square equals 6/9, etc. That's the sphere of the smallest. Any other sphere passing through this circle would have a radius larger than the radius of the sphere, of this circle. Got me? I don't think you'll need help with 13. Can you check that out? It's very simple though. If the line joining the origin and the point minus 2, 1, 2 makes an angle theta 1, theta 2, theta 2, theta 1, theta 2, theta 3, that means the direction cosines, right? See, this is O, 0, 0, 0. This is P, which has coordinates minus 2, 1, 2. This line has direction ratios. So a vector along this line is like a minus 2i plus j plus 2k, right? Minus 2 minus 0, 1 minus 0, 2 minus 0. This is a vector along this line. A unit vector along this line would be root 4, 8, 9, 3. This is a unit vector along the line. So the direction cosines of the line would be L would be like minus 2/3, M would be 1/3, N would be 2/3, right? These would be the direction cosines of the line, and this would be like a cos theta 1, this would be cos theta 2, this would be cos theta 3, right? And then what we need is cos 2 theta 1, summation of cos 2 theta 1 kind of terms. So cos 2 theta 1 can be written as 2 cos square theta 1 minus 1, etc. So cos theta 1, cos theta 1. Two parallel lines, their direction ratios will be proportional. Next problem 14. Two parallel lines, their direction ratios will be proportional, isn't it? That means minus 3/4 lambda plus 1 will be equal to 5 mu minus 3/4 will be equal to 6 by minus 8. You can solve lambda. The square of the perpendicular distance of a point P, PQR from a line through ABC and whose direction cosines are L, M and N. So then there is a line that passes through a point A whose coordinates are A, B and C, and the direction cosines of this line are L, M and N. That means a unit vector parallel to the line is like a Li plus Mj plus Nk is a unit vector parallel to the line, right? The square of the perpendicular distance from P, this is P with coordinates P, Q, R. We need to find the square of this length. We need to find the square of PD. We need to find the square of PD. We realize that PD is AP sin theta. PD is AP sin theta. PD is AP sin theta. And the vector AP cross a unit vector along this, that is Li plus Mj plus Nk. would be what? Magnitude of AP into magnitude of this, which is 1, into sine theta, isn't it? The magnitude of this will be what? The magnitude of this will be magnitude of AP into magnitude of this, which is 1 unit vector, into sine of the angle between these two, that is sine theta. That means to get AP sine theta, if I can carry out this cross product and then take its modulus, we are done. Isn't it? You know what I'm saying? To find this length, we actually need magnitude of AP sine theta. Magnitude of AP sine theta can be obtained from this cross product and then obtaining its magnitude. That will give me AP sine theta. Clear? So then the whole problem boils down to evaluating this cross product and then taking the magnitude of that cross product, right? And now what AP? The vector AP is P minus A I cap plus Q minus B J cap plus R minus C K cap. That's a vector AP. And AP cross this is this determinant I J K and then P minus A, Q minus B, R minus C, and then L M N, isn't it? That's this determinant. This, and we need to take the magnitude of this determinant. We need to take the magnitude of this, which is no rocket science, because this is like magnitude of Q minus B into N minus R minus C into M I cap minus J into P minus A into N minus R minus C into L J cap plus K into P minus A into M minus Q minus B into, right? When you expand the determinant, we need to take the magnitude of this. Clear? And the magnitude of this would be what? Root this square plus this square plus this square. That's a magnitude. That means root summation of this square. Root summation of this square. Q minus B into N minus R minus C into N. Right? Magnitude of this would be root this square plus this square plus this square. Q minus B into N plus R minus C into M, which is this. Option C. Option C. Option C, therefore. That's the summation that we have. Q minus B into N. Oh, sorry. Yeah, minus R minus C into M. Yeah, minus. A. Option A. Option A. Okay, so we have in problem 17 a line which is like x plus 1 by p is y minus 1 by 2 is z minus 2 by 4 and a plane which is 2x plus y minus 3z plus 4 equal to 0. This is the plane and this is the line. We need to find the angle between the line and the plane. Okay, now a normal to the plane is like 2i plus j minus 3k is a normal to the plane, right? A vector parallel to the line is like 3i plus 2j plus 4k is a vector parallel to the line, right? Isn't it? Now, say theta is the angle between, theta is the angle, this is the plane. This is the line and this is the normal to the plane. This is the normal to the plane. Normal. This is the line cutting through the plane. If theta is this angle, that the line makes with the plane, then it makes with the normal 90 minus theta. 90 minus theta, yes or no? That means I can find the cosine of the angle between the normal and the line. Cosine of this angle would be what? Cos 90 minus theta would be what? The cos of the angle between the normal, that means angle between these two lines, this vector and this vector. This vector is along the normal, this vector is along the line, isn't it? So that's going to be the dot product, which is 6 plus 2 minus 12 divided by 9, 16, 25, and 4, 29, 4, 13, and 14. That is 4 by magnitude. If you take magnitude, then magnitude 4 by this, that will be cos 90 minus theta, that is sin theta, etc. Right? So sin theta is known, theta would be sin inverse this, etc. Clear? I hope you realize, I hope I've confused you, all of you understand this. Theta is this angle with the plane, so with the normal, it's 90 minus theta. And cos of this angle, this dot this, divided by magnitude of this into magnitude of this. That's a cosine of the angle between these two, that is cos 90 minus theta, etc. Clear? Can I wipe this off? Wipe this off? Coordinates of the center and radius of the circle. I mean, intersection of a plane with a sphere would be a circle, isn't it? Intersection of a plane with a sphere would be a circle, right? So we have a sphere and we have this plane. We have this plane. This is the plane. This is the plane cutting through the sphere. This is the plane cutting through the sphere, which will give me a circle. Which will give me a circle. This plane is x plus 2y plus 2z equal to 15, and the sphere is like a x squared plus y squared plus z squared minus 2y minus 4z minus 11 equal to 0. That's the sphere. The sphere has a center. It has a radius r. The center of the sphere is like minus 2y, there is no x term, right? So 0, 1, 2, that's the center of the sphere, right? The radius of the sphere would be root this squared plus this squared plus this squared, that is 4 plus 1, 5, minus 11, that is 16, that's 4, root g squared plus f squared plus h squared minus c kind of thing, same formula. So radius is 4, and this is like a 0, 1, 2. And can you not find P, the perpendicular distance of this point from this plane, right? Plug in x equal to 0, y equal to 1, that is 2, and z equal to 4, minus 15, magnitude of this, divided by 8, 9, 3. That's P. 3 units. Straight formula, right? So this is 3 units. So this would be like 16 minus 7. Root 7 units is the radius of this circle. Right? And, well, in this case, options will suggest, so there is only one option. There could have been none of these also, very cynical sense, but then unlikely. C, and then this point, the center of this can also be, checked by options, because realize that if I actually look at 1, 3 and 4, 1, 3 and 4, then what are the direction ratios of this? The direction ratios of this are 1, 2, and 2, isn't it? The direction ratios of this are 1, 2, and 2, but this is also normal to this plane, and normal to the plane 1, 2, and 2. That's the direction. Distance formula also, yes. Distance between these two is root 7. Distance between these two is root 7. Absolutely. So, C. Option C. Equation of the problem 19. Equation of the sphere with center on the positive z axis This is the sphere. And its center on the positive z-axis means the center must have coordinates 0, 0, lambda. Where positive z-axis means lambda would have to be greater than 0, right? Center of the positive z-axis, which passes through the circle x squared plus y squared equal to 4 and z equal to 0. Z equal to 0 means the xy plane, and the circle, therefore this circle has center C, which is 0, 0, 0, 0, 0, 0, because this is x squared plus y squared equal to 4 on z equal to 0. So this is 0, 0, 0, the center C. And radius of this is 2. Radius of this is 2, isn't it? This distance is magnitude of lambda. This distance is magnitude of lambda. And the radius of the sphere is r. Radius of the sphere is r. So evidently, you have like r squared equal to lambda squared plus 4. Pythagoras theorem. And the equation of this sphere is going to be x squared plus y squared plus z minus lambda whole square equal to r squared, right? Equal to r squared, isn't it? Which is like x squared plus y squared plus z squared minus 2 lambda z equals r squared minus lambda squared. X squared plus y squared plus z squared minus 2 lambda z plus lambda squared goes on that side is r squared minus lambda squared. Hey, but r squared minus lambda squared is 4. So then the right hand side is 4. That means the only thing that we don't know is lambda. Only thing that we don't know is lambda. We need to find the value of lambda. Now, there is yet another condition given in the problem. It's cut by the plane in a circle of radius 3. It's cut by the plane in a circle of radius 3. This is a plane. This is radius 3. This is small r, right? And this plane is x plus 2y plus 2z equal to 0 is this plane. Is this plane, right? So perpendicular distance, this distance is known to us. Perpendicular distance of 0, 0 lambda from this plane is going to be 2 times magnitude of lambda divided by 3. So the lambda is positive, so 2 lambda by 3 is this. Perpendicular distance of 0, 0 lambda from this plane is 2 lambda by 3. So then apply Pythagoras theorem here. You have like r squared equal to 9 plus 4 lambda squared by 9. And then you can plug in r is lambda squared by 4. Lambda squared plus 4 equal to 9 plus 4 lambda squared by 9. 5 lambda squared by 9 is 5. Or lambda is 3 because it's given that it lies on the positive z axis. So lambda can't be minus 3. Lambda is 3. So just plug in lambda equal to 3. You get minus 6z minus 4 equal to 0. That's the equation of the required theorem. Now we have a plane, a variable plane that passes through a fixed point A, B and C. Next problem, problem 20. A variable plane passing through a fixed point A, B and C. The locus of the foot of the perpendicular from the origin, this is the origin, this is one sample plane. I mean, it can rotate about ABC to produce very many planes. We need to find the locus of this point P, X, Y, Z. while this sphere, this is rotated, we need to find the locus, right, where P is the perpendicular from O onto this. Now, fairly simple, because realize that a vector along this is like x minus 0 plus y minus 0j plus z minus 0k. That's a vector like this. And a vector along this is like x minus a I cap plus y minus b j cap plus z minus c k cap. That's a vector along the plane always, right, where x, y, z could be variable. And if this p is the foot of the perpendicular, then this dot, this will always be 0, right? This dot, this is 0, means x into x minus a plus y into y minus b plus z into z minus c is 0, which obviously is a sphere, because you have like a x squared plus y squared plus z squared minus ax minus by minus cz equal to 0. The radius of the sphere, as we've seen, is like a by 2 whole squared plus b by 2 whole squared plus c by 2 whole squared. Half of the coefficient of x, y and z squared, etc. is half of root a squared plus b squared plus c squared. That's the radius of the sphere on which this point xyz lies. So this path traced by P is going to be a sphere whose radius is this, and whose center is going to be a by 2, b by 2 and c by 2. If it was just about finding the radius of the sphere, then we didn't have to do this. This is 90 degrees. The radius of that sphere would have been half of this length. Think about it. Okay, I know all of you have not attempted the sheet completely. What I'll do is I'll teach a few things now. Go back to a little bit of calculus, some basic transformations which I want to communicate to you. Simple stuff. Listen to me. We may not be able to finish the whole thing today, but we'll at least get started. In the meantime, you continue with the sheet as well, so that beginning of the class, next class, if you're stuck up with any one of the remaining problems, shouldn't be stuck up because it's simple. You can, in any case, ask me to solve those problems on the board for you, right?